Hello, Internet. Hello. Today we are going to play with PyOxidizer. PyOxidizer is a toolkit for packaging Python projects as executable. Let's go over to their GitHub. It is managed by Indy Greg, which is apparently one of the nicer, reproducible Python coders in the open source community. He also has his the Python build standalone packages, which are quite nice, and also PyOxidizer, both of which are projects that take a really like these projects make reproducible Python project make Indy Greg produces high-quality Python projects that aim to help redistribute Python in a really manageable fashion. Now let's so if we read the small lines here, what it says, it's a utility for producing binaries that embed the Python interpreter itself, which means this would need to wrap all the complexities of packaging, importing, building, linking everything together. So we will have a nice executable that is basically completely standalone. I'm not sure, things like the PYC files, I'm really not sure how it will handle that, but we will see that. So with that now out of the way, let's try and figure out how to use this tool. I haven't used it yet. There are some docs here, and we will just try to figure out what can we do with that. So welcome to the unified documentation of the PyOxidizer project, a collection of libraries and tools attempting to improve ergonomics around packaging and distributing Python applications. The official home is the GitHub project. Official documentation lives here, unreleased, latest release. So we are in main right now, which is the correct version, because we are basically trying to use the cutting edge stuff. Maybe let's go to the stable one, just because this is the one we're going to pip install, but I'm sure there isn't much of a difference. But if there is, we'll go back to the bleeding edge docs. So first of all, apparently oxidized importer. So are we supposed to use this importer in order to make sure everything's fine? I'm not sure. PyEmbed should be able to embed the Rust, the Python runtime in the in a Rust application, and PyOxidizer is the one that's packaging us. So we are here we are aiming to use the PyOxidizer. Let's go over for the overview, and then we'll actually go to the getting started docs, and we'll try to make use of that. From a very high level, PyOxidizer is a tool for packaging and distributing Python applications. We've already read that. Overarching goal. Okay, so this is basically just the main doc here. If I recall correctly, this looks exactly the same. Capable of producing single executable files. Oh, so no, it's not exactly the same. So where does this doc come from? Does it come from here? Index RST. Okay, so this is another one. Interesting. I'm not sure, I'm not certain where these ones lie specifically, but maybe here. These are the docs. Okay, so PyOxidizer RST. Oh. Interesting. Okay, I'm not sure where these docs come from. Let's just ignore that. Basically, on a lower level, more technical level, it's a command line utility, PyOxidizer, that's capable of building binaries, variables, or libraries that embed a fully functional Python interpreter plus Python extension and modules in a single binary. I would imagine it uses something like basically a very nice executable plus a zip file that has all like an executable with a zip file embedded in it, or the other way around, to make sure like everything is bundled up together with the file system. Highly portable and can work on nearly every system without any special requirements like containers, fused file systems, or even temporary directory access. On Linux, PyOxidizer can produce executables that are fully statically linked that don't even support dynamic loading. Okay, interesting. The oxidizer part comes from the name Rust. Yeah, I at least understood that immediately, but never mind that. What else do we actually need to do? The existence of Rust should be invisible to many users, much like the fact that CPython, the official Python distribution, is implemented in C. Yeah. So basically, we should hope that the implementation language of this packager should be invisible to us if everything is done correctly. Benefits, ease of installation. Okay, so I'm pretty much sold on this idea of why we should do this, because I would really love that people could build their tools in Python and they could ship like working binaries to people without ever explaining to someone how to bootstrap their virtual environment and how to install requirements, because this is just pain for a lot of people. Basically, the fact that I love one package manager and you love another should mean that when I ship a Python project to you, you wouldn't be able to run it just because you don't have like the package manager installed on your system path. How it works, probably not interesting right now. Maybe we'll deep dive into how it actually works internally later. Let's just get started. So we apparently this tool officially supports Windows 32 bits. I'm surprised 32 bits are still supported, but basically macOS ARM and Intel, Linux Intel only, and Windows Intel only. As you can see, like the fact that Apple has the M1 Apple Silicon devices basically forces everyone to also support ARM. But also, when you think about it, like there's also a lot of servers that use ARM processors, and once we would have Python tools running around that you would want to distribute them also to Linux and on ARM, then that tool would be useful to basically have that plug and play support later in the future. And what would we need except for the PyOxidizer tool itself? We'll need a working C compiler and toolchain in order to build the binaries. If a C compiler cannot be found, you should see an error message with instructions on how to install one. So this is the point. This is the place where I would really have appreciated that also this tool would come with its own small C compiler that might not be the best compiler, but with the latest and greatest features, but basically that this would also come bootstrapped with the compiler itself. On macOS, we would need an Apple SDK. So I think we should probably have that. See build machine requirements. And by the way, we would probably also want to maybe at some point create a tool, initialize it, and then push to GitHub Actions, and then GitHub Actions basically build all the artifacts and save them in a bucket or somewhere like in an artifact repository where you could basically just pull it down and just start using it without thinking about it. There are known issues with PyOxidizer and Fedora. I don't care about that. And while it is implemented in Rust, involves the Rust compiler, blah, 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 blah. PyOxidizer manages a Rust installation for you. So this is the point where I'm like a bit dissatisfied, because if it already manages the Rust toolchain, why not also manage the C toolchain? The answer for that, by the way, is because managing C compilers is horrible compared to like using Cargo, which is delightful. And let's just move on and stop ranting. These installers can be generally found at the releases. Okay, that's very good. If the URL does not redirect, we can just go there. Let's figure out. Yeah, is this the right last release? Apparently so. That's probably incorrect. If we go to the code, we can see, yeah, okay, so no, that's definitely not it. Main. Okay, so latest update on January, which is kind of sad. I was probably thinking this would be more maintained, but apparently it's not. Okay, we'll give it a shot, but no promises whether it will actually fail or not. Let's install PyOxidizer. This is where installing the tool globally is actually nice because this is not a project-specific tool. This is basically, we just want the latest and greatest PyOxidizer in our system path. By the way, I'm experimenting with Rye. If you haven't seen the video on it, it's a nice Python package manager tool, which is very bleeding edge, but so far I'm very happy with it for like small side projects. Okay, so we do have PyOxidizer. We can also always upgrade it by probably running Rye install again or something like upgrade. Or maybe Edge. Interesting. I can also probably like tell it to use like a specific branch or a revision. Yeah, that's nice. But where the like upgrade thing, I really would have appreciated just no upgrade. Surprised. Right, install options. I wonder if I dash force that, this will update. Okay. So not amazing, but should work. If we open now a new tab, this will be in our tool, PyOxidizer -- shelf. Okay, that's nice. So right now we do have our PyOxidizer with us and installing Rust. Installing PyOxidizer for source, that's not interesting because we can just move on. So getting started. The command line tool, configuration files, packaging user guide. That's the one we are aiming for, I think. Let's figure out just to make sure we don't need anything else. We could have also installed that through Cargo. That's actually nice. That means that's actually even better than using like my hacky way with Rye, but that's not like Rye is not that hacky, but using Cargo for installing a Rust project is probably the way to go. So I would recommend that next time. Danger, cargo build from the repository root will likely fail due to how some Rust traits are configured. Okay, so your first PyOxidizer project, that's the one we actually aim for. So init config file, let's do that right here. Path, this directory. And we are here, and now PyOxidizer run. Resolving one target, resolving target install, target exe. Okay, so that's quite nice that it has like it's now using basically Rust up to bootstrap the Rust toolchain without us needing to think about it, even though I do have a working Rust toolchain, which is, by the way, like the easiest toolchain to install ever. But yeah, still nice that it does not rely on me to manage that. While this is running, this will probably work. Oh, build failed. Python executable to manifest. And it says, adding Python executable to project caused by cargo build failed. Um, let's look at the Bazel file here. And let's actually figure out what's wrong with it. So, the thing I'm worried about, sadly, is something like because I handed it not a relative, the relative path was like dot, it might have broken some things here, just like this one, just like the dot here, which I'm not sure is the right way to go about this. So we might wanna clean this up and try again with like an empty directory with nothing fancy going on here. But let's also figure out if we actually need to do anything fancy here. It says compiling PyApp. For us, did it mention PyApp here? And it says resolving created binary warning. A lot of warnings. Not really a warning. It seems like just bootstrapping everything. Okay, so I'm saying let's nuke this and run this in a clean way. So PyOxidizer init config file, hello PyOxidizer, and it will say writing to Bazel file. And now we can cd into that and PyOxidizer run. And it's now compiling again. It seems like it's doing a lot of compiling, which is a good thing. We have nothing here though in terms of like Python, which I'm supposedly this should not work, or it will produce an executable that embeds Python and starts a Python REPL by default. Interesting. So that means when we call PyOxidizer run, it will also actually execute that. And we can now actually print hello world from our self-contained binary, which is nice. And do we actually see that binary? Yeah. So we've got here our build. Within it, we've got our hello PyOxidizer. And that's probably a quite heavy binary because it ships the full Python runtime. Yeah, with the 70 megabytes, it's actually, yeah, probably the full Python runtime. We can also probably extract like a lot of strings from that executable to actually verify that's the Python runtime or some of it. So Python, let's go for like something like a foundation. Yeah, so the Python software foundation, that's like the string of the license, which should be embedded here. So a lot of stuff is probably embedded here. Oh, the full standard library should be here. So iter tools, yeah, basically a lot of crap should be embedded in this in this executable, like a lot. Okay, very cool. So this is basically shipping just Python, which is nice, but not the thing we aim for because we want to not just embed Python, we want to actually embed our own scripts. So how do we do that? To exit the REPL, press Control D or Control Z. That's we're already past that. And continue reading the PyOxidizer command line tool to learn more about the PyOxidizer tool, or read on for a preview on how to customize your application's behavior. So the .bazel file is very important. This is a Starlog file. Starlog, by the way, is just a subset of Python. If you are not aware of that, then you should go and like look it up. It looks like basically like ugly Python. And this is probably where we're going to define a lot of our build configuration. We'll figure out what's the actual. Oh, that's nice. Ooh. So, that's a really nice thing. Okay, let's edit that. So, let's figure out what's going on here. Okay, so first of all, let's maximize and zoom in on this and command. So Python config run command. This one, and oh, I'm not used to Sublime key bindings. So let's just print a UID every time. Let's figure out how fast is it to run that now. So it should bootstrap everything, but I should hope a lot of it is like pre-compiled or cached. Doesn't seem like that, which is quite sad. I'm wondering what could make this build time shorter, because we're just changing the script. We're not changing the actual like none of the dependencies change. So I wonder why is this taking so long to actually build. But maybe because we're changing not really the script, but we're actually changing the build configuration in the Bazel file that actually, that's the one that's causing the rebuild because it's invalidating the actual definition of this of it's basically it's invalidating this configuration. So, and if we now run PyOxidizer again, it does not, it completely rebuilds it, but we do know that we can basically just run that directly through our build. So we can just go here and run that again. I'm actually surprised. I'm actually curious. How fast do you think it takes to generate a random UID with bootstrapping the entire Python runtime to just generate one UID? I would imagine it would take, I don't know, 50 milliseconds. Let's just run that and see one warm up. No, actually, let's give it the file system cache 2 runs for warm up, and let's run that. Oh, 20 milliseconds. That is way faster than I thought. And also, by the way, it's very consistent, like plus minus 1 millisecond. That's quite nice for a thing that bootstraps an entire runtime just to print out a thing. Of course, this is probably terrible performance if you only want to generate one new UID. But I was just curious. Anyhow, by the way, Hyperfine is a really nice benchmarker. As you can see, it's really easy to just throw at it an executable and let it run, and you get some nice statistics without a lot of trouble. Okay, so we have packaged our own command. How do we package our own script with actual dependencies? That's the actual important and interesting thing here. So that has worked. Yeah, pretty trivial. So let's package an existing Python application. So find the exe equals this to Python executable line in the .bazel file. So let's find that. First of all, our command here, we comment it out again. And let's, oh yeah, so this to Python executable. And it now says name, hello PyOxidizer, packaging policy. You can look it up, see what policy actually equals to, but policy equals to make packaging policy. Okay, anyhow, let's add a new line where make exe to make exe just below where the exe is assigned. Sure. Exe equals, yeah. So just below that, it said paste this code. And what does that do? It says pip install pyflakes. First of all, the fact that it says just pip install, that's quite nice, but because that means we can easily like pass here whatever we want here, and that would quote unquote just work. I hope. Add location in memory. Interesting. I'm not sure what that means. And add Python resource. Okay. In addition to that, let's edit the run command to this one. So from PyFlakes API, import main and then call main. Just to be clear, I think if I'm not mistaken, PyFlakes is basically PEP 8 thing. Maybe I'm wrong, but PyFlakes. Okay, so it's not PEP 8, it's basically just a linter though. Text source code file for errors. Interesting. Okay. Works by passing the source file, not importing them, so it is safe to use on modules with side effects. It's also much faster. Anyhow, okay, cool. So we are basically pip installing some pure Python dependency, probably. I would imagine this is not a C extension and actually just Python. Yeah, 100% Python. Obviously by Anthony Sotile, which is one of the awesome people in the Python community. If you don't know what he does, then look up pre-commit and all sorts of like a lot of useful, very useful Python tools. Anyhow, let's just run that, and while that is running, let's continue on with well, reading on the docs because they are so far very, very useful and very, very informative. Okay, so while this is running, this just produced an executable for PyFlex, which is, yeah, very nice. PyFlex with no command arguments will read from standard in and will effectively hang until stdin is closed, basically, typically via control D. So the dash dash in dash dash help in the above example is important because it forces the command to produce output. Okay, so we can basically just do that. Yeah, okay. While this is running, we can move on to the next thing, which is how do we actually package our own scripts and not like a pure Python thing? Or maybe actually that actually does it because we can basically just pip install ourselves. We can pip install like an editable version of our own package with PyOxidizer, and that would basically package that into a CLI. I wonder if that is the only thing that we need to do. I don't know. Let's just go for the packaging user guide and see what else do we need to do. So we have created our own project. That we did. We can now define targets define actions. Wait, packaging primitives. Okay, so this is probably important. So how do we actually package things? Runtime behavior is controlled by the PyOxidizer Bazel Starlock file, blah, 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 blah. As detailed at targets, the PyOxidizer configuration file is composed of named targets, which are functions returning an object that may have a build or run action attached. Commands like PyOxidizer build identify a target to evaluate, then effectively walk the dependency graph evaluating dependent targets until the requested target is built. Defining an executable embedding Python. Make exe, dist, default Python distribution, dist to Python executable, my app. Okay, seems reasonable. Register target, exe, make exe. Cool. Resolve targets. Okay, seems reasonable. Okay, so we've done that. So what we do here is basically we take the dist, the Python distribution, we make an interpreter config, and then we basically, this is probably like the -c command for the Python interpreter. The Python interpreter config type exposes a lot of modifiable settings. The API documentation see the API documentation for the complete list, but we can control low-level Python interpreter settings, whether like, okay, so we can, yeah, basically we can control everything that is controllable by the Python CLI. By the way, yeah, okay, so PyFlex is now hanging because, as we've said, this is now, yeah, this is PyFlex. Right? Is this PyFlex? Yeah, okay, so check Python source files for those. Yeah, this is definitely PyFlex. Okay, very nice. Okay, continue moving on. Adding Python packages to executables. This is the thing that we want to do. Install manifests, copy files next to your application. That's also quite interesting because we do need to sometimes bundle up non-Python code within our Python files. Okay, so it just created Python executable starlog. A type contains just the Python interpreter, a standard library derived from the Python distribution from which it came from. While you can use PyOxidizer to produce an executable containing just normal Python distribution and with nothing else, many people will add their own Python packages / code. The starlog environment defines various types of for representing Python packages resources. These include Python module source, extension modules, packaging distribution, and more. Instances of these types can be created dynamically or by performing common Python packaging operations, such as invoking pip install. Via various methods on Python executable instances. These Python package resources instances can then be added to Python executable instances as part of the build binary. Okay. So manage how resources are added. Packaging Python files for more on this topic. So probably packaging Python files would be the way to go here. So we can pip install, pip download, read package root, set up PyInstall, read virtual env. Okay, all of these are quite nice. Recursively scan the file system directory resources in a typical Python installation layout. So I think this is usually the way to go, just with that. But that won't do us the thing that we want, which is to install all of our dependencies. So I'm not sure. Okay, this seems like we just need to read the docs more. Packaging an application from an existing virtual env. This scenario is very similar to the above example, so we'll briefly describe it so we won't repeat ourselves. We init my app, then we edit the config, the Bazel file. Looks like the following. Extension module filter all, include distribution sources true, include distribution resources false, interesting. Include test false. Oh, that's nice. So we can update our packaging policy to not include basically things we don't want to be included, like tests, which is nice. So this to Python executable packaging policy, this one, it says from my app import main, and we just need to add Python sources, and we do that by reading the virtual env. So this is peculiar because if we want to use something to like this is introspecting into a working virtual app, which is something I would say is good because we need to populate it and actually make sure it works. And that means it will work specifically with the virtual env on the machine that did that. Which I'm not sure is that very reproducible, because it really depends on our like builder machine. Anything better to do here? Because repopulate virtual envs. Yeah, this may be compatibility different. Yeah, there may be compatibility differences between Python distributions used to populate virtual env and the Python distribution that we actually distribute. Yeah, okay. Any other solutions except for pip install path to local package? That's not a good way to go. In this mode, all Python resources must be already in place in the final installation layout for things to work properly. Many setup Py files perform additional actions such as compiling Python extension modules, installing additional files, dynamically generating some, and okay, so choosing which packaging method to call. Pip download will only work if a compatible Python wheel package is available. So that's not very nice. I was thinking this would be a little bit nicer in order to actually package stuff. I mean, it is doing what it's supposed to do by basically pip installing everything and just making it work. And probably the way to go is basically to use pip install on the local directory, and that would basically like do all the magic. That means it will respect our actual build system and would package everything up. But that also is dependent on the actual runtime that does the pip install, which might be a little different than the one we're actually using. Maybe, I'm not sure. Let's actually confer with the pip install thing. So pip install itself, not a lot of where's the path to local file? Yeah, okay. So we could use to process a local file system path. Okay, so we do have CWD as a global here, which is okay. That's probably the way to go. I believe this is the way to go. And then we can bootstrap our package with whatever build system we want. And it could be Poetry, it could be Rye, it could be Hatchling, could be I forgot the names of other like setup tools. Basically, any build system that you want, and it would just work. Maybe. Let's actually test that. So let's Rye init within our this project, and Rye pen 311 and Rye add hyper Rye sync, and let's change our starlog file here to install the current working directory, which is just this one. And location in memory, sure, I'm not sure that's the actual thing that we want, but we'll figure it out in a minute. So first of all, this should now be useful enough to basically have it work. And just to be sure, we can run this command now. We could just import what is it? So import hello PyOxidizer. And hello PyOxidizer dot main. And let's just or dot hello, because apparently that's the default. Is it printing? It does not print. So def main, and we can print hello from our own package. And to make sure everything is like also packaging the actual dependencies. So from typer import typer app equals typer at app command do the thing, and we could just call app then. Okay, so let's just call app. So app. This should do the trick. Let's run that. And if that works first shot, I would be surprised. But we'll figure it out because, okay, first of all, as you can see, it does install things using our package manager, which is the thing that we aim for. I really appreciate this thing. Does it install? I don't see it installing typo. So that's no good. Right? Typo was not installed. Oh, it was. Okay, collecting typo. Oh, it might be just working, which is amazing and unexpected. Like things do not work usually in Python end. And it says hello from our own package. Oh my god, that work? Holy shit. It just did. Okay, so there you have it. It's just working. So basically, if you have a reproducible build step on the Python side, then this will basically wrap it up with just installing the current project. And then if you go the PyProject TOML way of basically installing everything like that, and you have a sane build system, it would just package everything up and would just do the thing that it's supposed to do. So that is really nice. I'm surprised it actually took the requirements from this file, from basically from the local project. I wonder how did that connect together, because this is managed by, well, Rai. How did it work? I'm now wondering. Um, Python, um, yeah, import. What's the name of this package again? I'm always forgetting. Yeah, hello PyOxidizer. So yeah, so it's already installed in our virtual environment, so that should just work. Um, sorry, app. Okay, wow. Okay, just working, magically working. Not magically, but I mean, a lot of engineering went into this tool to make it basically reproducible and do the thing. But it does the thing, which is very nice. Okay, so in conclusion, what we have done today, we have read some documentation about PyOxidizer, which apparently is not very well maintained, but apparently still it is working, which is usually a good thing to say about a tool that has been abandoned for almost a year and it is still in good shape. And it's just packaged up a Python interpreter with our own crappy script, with our own with some of our dependencies. Let's actually also, you know what? Let's make it let's say +1 this difficulty and install something which ships a binary. So try add numpy. So NumPy is a special thing, like it's a package that does math, but the thing that why I aim for that library is because, well, it's without other extra dependencies, so it should be sufficiently sane to basically use that. So let's just edit our small, what's it called? Our dunder init file. Let's just import numpy as np, and let's produce a random number every time. So here is your random number, and we can just print. Yeah, okay. Very nice. And let's just try, and not try, let's PyOxidizer run this. And it should now also install NumPy. So this is basically just very good. It defaults to Python 3.10, which I'm unaware of, like how does it choose the actual Python thing. And it says add Python resource. Interesting. So it says extension module NumPy call multi-array test cannot be loaded from memory because the memory loading required blah 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 blah. Interesting. Cannot be loaded from memory. So why does it say load from memory though? Do we need that? Let's just let it decide by itself. And that might just be working. So no, in memory it is the default. I'm not sure. Okay, so this is the what I said about like one-upping the actual difficulty of this. Binary. Okay, so PyOxidizer will collect all downloaded installed resources like modules, blah 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 blah. It will return them as an iterable of starlog values. The exe add Python resources will call them and teach the built executable binary about the existence of each resources. So how are we going to do that? Let's figure out PyOxidizer, NumPy. Unable to use NumPy. So it is open. Interesting. Packaging C extensions from pre-built virtual enums won't work. This needs to be documented better. C extensions will only be packaged for packaging rules that invoke pip or setup py. But and when I try this myself, the NumPy package takes forever to build. When I see it compiling object files, but PyOxidizer doesn't pick up the build C extension. Interesting. Today I learned NumPy vendors its own complete copy of DistUtils, which it has modified for its own personal gains and uses exclusively as part of builds. Interesting. Okay, so packaging binaries still does not work correctly, which is quite sad. Do we have a way to fix that somehow? Probably not. I was able to get NumPy to work with Nukita, but not with PyOxidizer. I haven't tried since I opened the bug report, and it looks like there's been 9 commits since. I should try again. For what it's worth, it appears to be able to build NumPy with PyOx, but I'm running into issues with that it requires Dundle file. Mac. Okay, so for now, packaging still sucks, and just don't use binary tools. And if you do, then you're fucked, and you cannot use this tool properly. Oxidized importer, file system importer, true. Interesting. So not the best thing. we could have done, that we could have had, but still very good. Okay, so basically this will just help you package pure Python CLIs and not like pure Python executables. Don't expect it to completely wrap up like C extensions with your project. Could we do it better? I don't know. Yeah, that's kind of sad. Try remove numpy, and we can run that again. And that should now package everything, except that it will fail on import time because I forgot to do the thing, which is to remove this thing and this thing. So we can import random, just use our own small random int here, sure. But that's not like what we came here for. We came here for packaging numpy, and that won't happen, sadly. So I'm sorry to disappoint. This is for packaging pure Python scripts only for now. They might fix that in the future, but it is really a pain to ship like binaries, like in libraries within your Python project. So I'm super understanding of like that not being still possible. Anyhow, that was fun. I really like covering new Python tools and in the ecosystem. And let me know if you actually enjoyed learning about that. So until then, see you on the next one.